Welcome to The Explainer. Today, we are embarking on an absolutely epic journey. We're going to virtually glide through the universe to explore a structure so unimaginably vast and so breathtakingly beautiful that it honestly kind of defies human comprehension. Yet, at the same time, it is the most intimate cosmic structure to us. It's our very own cosmic home, the Milky Way.
On a dark night, far from city lights, a faint river of stars stretches across the sky. Ancient civilizations called it the Milky Way, never imagining it was actually our home among hundreds of billions of stars. Just let that sink in for a second. For millennia, humanity looked up at that milky white band of stars, gas, and stellar dust, and we saw it merely as a brushstroke painted on the canvas of the night sky. We had absolutely no idea that we were actually looking out from the inside of a sprawling, massive galactic city.
Now, you might remember from our previous explorations, we've talked about the grand architecture of the universe, right? How galaxies formed along this vast, glowing cosmic web of dark matter stretching across the expanding void. But now, the story becomes incredibly personal. We're zooming all the way in from that impossibly large cosmic web down to our specific address. The ultimate question we have to ask today is, how did our own galaxy come into existence? How did those early, chaotic elements organize themselves into the spectacular, swirling spiral that we actually live in today?
Okay, let's dive into this timeline. The story of the Milky Way begins in deep time, roughly 13.6 billion years ago, just shortly after the Big Bang itself. It all started as small overdensities. Picture these massive, invisible halos of dark matter. You can think of dark matter as the invisible scaffolding of the universe, providing the gravitational glue necessary to pull in vast, sprawling clouds of pristine hydrogen gas. Within these collapsing clouds, gravity worked its magic and the very first ancient stars ignited. These oldest stars, which we actually still see today in tightly packed spherical groups called globular clusters, well, they represent the absolute dawn of our galactic history. Over the next few billion years, that gravitational glue relentlessly pulled smaller proto-galaxies together, merging them into a larger, far more massive structure.
So our galaxy literally grew by aggressively devouring its neighbors. Cosmological simulations and fossilized stellar data reveal that about 11 billion years ago, the early Milky Way underwent a massively violent collision with a particularly large galaxy that astronomers have brilliantly named the Kraken. This dynamic merging was chaotic. It was incredibly destructive, ripping star systems apart and forcefully churning the galactic environment to build the core mass of our galactic home. But what is truly fascinating here is that, based on the properties of its outermost regions, the Milky Way has been exceptionally quiet since then. It hasn't undergone any major violent mergers with large galaxies in the last 10 billion years. That actually makes it quite unusual compared to other spiral galaxies out there, leaving us in a remarkably tranquil cosmic era.
As the Milky Way grew massive enough, something really beautiful happened. Thanks to the conservation of angular momentum, this massive, chaotic, roughly spherical cloud of gas and stars began to spin up and flatten out. Picture a big lump of spinning pizza dough flattening into a wide, beautiful disk as it's tossed in the air. Within this flattening disk, continuous star formation took off at just an unprecedented rate. Countless gas and dust clouds collapsed under their own immense weight. The friction of this collapsing gas caused it to heat up more and more, until, eventually, billions of natural fusion reactors simultaneously blinked into existence. The iconic, swirling spiral arms began to take shape, turning the Milky Way into a magnificent, glowing vortex.
To truly appreciate this structure, we have to talk about its sheer, staggering scale. Our galaxy is roughly 100,000 light-years in diameter. It is home to anywhere between 100 billion and 400 billion stars, and likely more than 100 billion planets. To put that massive width into perspective, light is the fastest thing in the universe, traveling at 186,000 miles per second. Yet, even traveling at that blistering speed, a beam of light would still take 100 millennia just to cross from one side of our galaxy to the other. And despite this massive width, the disk itself is surprisingly thin, only about 1,000 light-years thick. But here's the wildest part. All this visible matter is enveloped in a massive, invisible sphere of dark matter that extends up to 2 million light-years wide. Dark matter makes up about 90% of our galaxy's mind-boggling 1.5 trillion solar masses.
All right, let's leave the outer edges for a second and take a cinematic flight inward. Imagine plunging past billions of twinkling suns, heading straight for the tightly packed heart of this galactic city. This is the galactic center. Right here, we find the galactic bulge. It's a dense, peanut-shaped region measuring about 10,000 light-years across. It harbors 10 billion stars all tightly clustered together, mostly ancient red giants that formed in the very early stages of the galaxy's evolution. It is a blindingly bright, chaotic, and incredibly crowded environment where stars are separated by mere fractions of a light year, which is crazy when compared to the vast, empty distances out in the spiral arms.
Now, what's really interesting about this is what's lurking exactly at the center of that bright bulge. It's a monster. Meet Sagittarius A star, a supermassive black hole with a mass 4.1 million times that of our Sun. Measuring about 14.6 million miles across, it acts as the gravitational anchor for our entire galaxy. Fortunately for us, it's currently a relatively dormant, inactive galactic nucleus. But, it still occasionally feeds on nearby gas and unfortunate stars. In 2022, using the Event Horizon Telescope, which is a network of observatories spanning our entire globe, humanity actually captured the first ever image of Sagittarius A star. It revealed the glowing shadow of superheated gas rushing at tremendous speeds around this ultimate gateway to nothingness.
If we pull back from the intense gravity of the black hole, we can observe the grand architecture of the galactic disk. Outside that central bulge, the Milky Way organizes itself into swirling, twisting spiral arms. Astronomers currently identify 4 main spiral arms, starting near the center: the Perseus arm, the Scutum Centaurus arm, the Sagittarius arm, and the Local arm. Now, these arms aren't solid, rigid structures. They are more like cosmic traffic jams, density waves where gas and stars bunch up as they orbit the galaxy. As the gas gets compressed in this galactic traffic jam, it triggers the birth of brilliant, short-lived blue stars. And that is exactly why the spiral arms light up so spectacularly against the dark void of space.
Visually immerse yourself in the anatomy of these arms. They are where the galaxy is most alive. They contain a much higher density of interstellar gas and dust than the galactic average, making them the primary nurseries of the Milky Way. They're packed with giant molecular clouds and HI regions, which are essentially these massive, gorgeous clouds of glowing, ionized hydrogen gas where new solar systems are actively being born. Interestingly, recent data from the Gaia Space Observatory shows that this entire magnificent disk isn't perfectly flat. It's actually warped. As the galaxy rotates, the disk precesses, meaning its axis of rotation slowly wobbles, kind of like a spinning top losing momentum. This wobble sends giant ripples through the spiral arms over millions of years, continuously shaping the intricate structure of our home.
So, with all this incredible, bustling structure, where exactly is our cosmic address? Well, Earth is located in a feature known as the Orion Spur, sometimes called the Orion Arm. It's a minor offshoot located right between the larger Sagittarius and Perseus arms. In the grand, bustling metropolis of the Milky Way, the Orion Spur is a relatively quiet, suburban neighborhood. When you step outside and look up at the night sky, most of the individual stars you see with your naked eye aren't distant galactic landmarks. They are actually our immediate neighbors right here in the peaceful Orion Spur.
We are situated a very safe 26,000 light-years away from the chaotic galactic center. And you know what? This distance is absolutely crucial for our existence. If we were much closer to the core, the intense radiation from frequent supernovae and the wildly crowded stellar environment would be incredibly hostile. In fact, that relentless barrage of cosmic radiation could easily strip away Earth's protective atmosphere entirely, completely disrupting our delicate planetary environment. So, from our vantage point halfway to the edge of the galaxy, we are perfectly positioned to enjoy a peaceful, stable existence, while still having a spectacular, edge-on view of the galactic disk stretching magnificently across our sky. But just because it's peaceful doesn't mean it's static. Let's look at how we are actually moving through this space. Using data from the Gaia mission, astronomers discovered that our sun is essentially surfing. Literally, we are riding a massive wave of interstellar gas that is 9,000 light-years long and undulates 500 light-years above and below the galactic disk. Furthermore, the planets in our solar system don't even orbit in the flat plane of the galaxy. Our solar system is tipped at a steep 63-degree angle to the galactic plane. As one astrophysicist brilliantly put it, it's almost like we're sailing through the galaxy sideways. It is genuinely awe-inspiring to think about our little planetary family cutting through the interstellar medium at such a dramatic, tilted angle.
And we are moving incredibly fast. Our solar system is hurtling through space at a speed of about 515,000 miles per hour. Yet, even at that blistering pace, the Milky Way is so impossibly large that it takes us roughly 250 million years to complete just one single orbit around the galactic center. This is known as a galactic year. To put that in perspective, the last time Earth was in this exact position in the galaxy, dinosaurs were just beginning to emerge, and mammals hadn't even evolved yet. Our entire human history is just a microscopic fraction of a single galactic year.
Let's zoom out even further, beyond the very edges of our galaxy, to see our broader neighborhood. Because the Milky Way doesn't exist in isolation. It's actually a prominent member of a galactic neighborhood known as the local group. This group spans over 10 million light-years and is bound together by an intricate web of gravity. It contains the Milky Way, our massive spiral neighbor, the Andromeda galaxy, and over 40 smaller dwarf galaxies that orbit the two giants, very much like moons orbiting planets.
Our galaxy is definitely not static. It's an active, living entity that continues to interact with its broader environment. Through a dramatic process called galactic cannibalism, the Milky Way continues to devour smaller dwarf galaxies today. We're currently accreting material from our largest satellites, the Large and Small Magellanic Clouds, pulling gas from them to form what's called the Magellanic Stream. You can picture this as a massive sweeping ribbon of stolen gas trailing behind the dwarf galaxies as they orbit us. Furthermore, another satellite, the Sagittarius dwarf galaxy, has actually smashed through our galactic disk several times in the past 7 billion years. And get this, scientists believe those very collisions triggered huge waves of intense star formation, one of which likely birthed our very own sun 4.6 billion years ago. A real game changer for us, right?
Which brings us to the deep future. While the Milky Way has been quietly absorbing small dwarf galaxies for billions of years, a much more dramatic event is looming on the cosmic horizon. Our massive neighbor, the Andromeda galaxy, is currently hurtling toward us through the local group at hundreds of thousands of miles per hour. Driven by their immense mutual gravity, a galactic collision between the Milky Way and Andromeda is absolutely inevitable. The skies of Earth, if anyone is around to see it in a few billion years, will be dominated by the terrifyingly beautiful, ever-approaching spiral of Andromeda until it fills the entire night sky.
So the crucial point is you don't need to worry about stars physically crashing into each other. Space is notoriously empty. The distances between individual stars are so unimaginably vast that during this merger, the stars of both galaxies will almost certainly just pass right by one another completely safely. However, the immense clouds of interstellar gas and dust, they will forcefully collide. This immense friction will compress massive amounts of material together, sparking a brilliant, intense new era of starbirth as millions of new suns ignite. Over millions of years, the beautiful spiral arms of both galaxies will be ripped apart by gravity, eventually settling into one single, massive, newly shaped elliptical galaxy.
As we wrap up our grand tour of the Milky Way, I want to leave you with this inspiring reflection. Every person who has ever lived, every mountain, ocean, civilization, and every dream exists inside one tiny, quiet corner of a single spiral galaxy. And beyond it lie billions more, each with stories of their own waiting to be discovered. You know, understanding our galaxy doesn't make us insignificant. It connects us to a breathtaking cosmic legacy of dark matter, ancient starlight, and swirling galactic oceans. What a time to be alive and looking up. But it leaves us with one final lingering question. If our entire history unfolded in just one quiet suburb of this single galaxy, what spectacular stories are playing out right now across the billions of other galaxies waiting in the dark? Thank you for joining me on this explainer, and keep wondering.